I'm Miabez. I work for the U.S. Army, and I'm going to be talking about LLDB today. And since it's mostly like a 30-minute demo of the greatness of LLDB, I'll be sitting down here, and I'll try to put the mic in the stand. And if you can't hear me, yell at me, and I'll grab it and do it with one hand. Like, yes, I'm a expert masturbator. All right, thank you. All right, so who here has used LLDB? Sorry. Who likes it? All right, there's a few people who like it apparently. So, but so in Max, you always had the wonderful yeah, GDB is 6.3, and then no Python. But Charlie Miller claims that it's possible to put Python into this. I hear rumors that yeah, I compiled GDB 7.7 and I code signed it and something something and I Mako and Lipo and then yeah, and then I hear rumors. Then I ask the guy like, really? Is it like no? It crashed on startup. But now, yes. So, but with Mavericks, you no longer get GDB also on the iPhone. So this also. Yes, and apparently I still have it because Pedro left it on or something. Um, but yeah, so I was forced to use LLDB to do the Mac computer thing or in the iOS thing, and then I thought I liked it, and I got accepted, and Ben's like, so it's really shitty, right? And then I'm like, no, it's awesome, and I start telling him how good it is, and then I realize how what I'm telling him, and I have Stockholm syndrome. It's actually really crap. And so one of the things is that, okay, so here's some kind of API to get the program counter. And a lot of the times it gives you the program counter. And but if you actually like put this into a Python file and execute it, then it'll just give you some random number. And then silently fail and you're like, oh, that's fine. And but now since it's not in a separate and then just going briefly over the awesome power of LDB is that command history here in the channel that's is set to 800 lines. And they do set unique one. Here's a LLDB command history, and it has like 80 instances of continue out of the 800 or so lines. So, thank you, LLDB. But if you LLDB yourself, then you change this, but then you have to mess with something called RPath, which is hard. So so then to get over this problem of getting the wrong register values, I figured I can just do RERE. From Python, I tell the command interpreter of LLDB to run RERE, and then I just parse the regex. And then I get this, and I was doing this, and I wrapped it in Python, and I forgot about it, and then I'm telling Ben, and then I realized that, oh, this is horrible. But it sort of worked until I got a multi-threaded program, and so here's the help, and so when you get to the point and then you do RERE on the command line, then you get the registers for the current thread. But if you're doing it from Python, you get them for thread 0, no matter which thread is stopped, which is optimal, especially since the weird command for register read doesn't allow you to specify which thread you're talking about. So then I can just so here. So first I iterate in a weird thing. I iterate all the threads and ask to get the which thread is now stopped, which sometimes returns that one of them is stopped. And then I go from there and I go through the wonderful API thing, registers, and I compare REX, and then I can get the values. But sometimes, so, oops, okay, here. So, oops, probably not the right thing. Let's. Um, okay, so now here, so no threads were stopped. I went through them and there was nothing there. And as you can see, my software is called Greatness. And to fix this, you can reload the module. Now I found a stop thread. Cool. Sometimes reloading doesn't work. It's still broken, but instead, if you go in and comment your debugging statement where you print out the thing where you say, oh, what's the stop reason for each thread, then it starts working. And then that's how you work around this issue. And this is just one of the many issues. And here, so here in on Stack Overflow, there's this question, blah, 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 that basically says he wants to run multiple commands on one line, and or in one command, he wants multiple things. And this guy answers yes. So the point is, there was a deliberate decision to avoid blah, 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 blah. They, on purpose, made the syntax, everything. So instead of doing something like this, they want you to do this one. And it's so that you would do everything in Python. And then so this guy who replies, he's called Jason. With the mic. So then I on Lldb, and I wanted to see if Jason Melinda is legit, and then I see that there's 2 commits by him, someone else 2 by him, and then more by him. So he's like developers, so we can trust him on this. So neat thing about Lldb that apparently other debuggers do not have, like GDB or WinDebug, is that you have this thing called expressions, and it comes in handy because all the features that are actually in the other debuggers, like showing the permissions for a memory region, Lldb doesn't have that feature, and so then you need something weird to compensate for this deficiency, and it has this thing called expressions, where basically you say, you created into the address space of the process an integer 1, and then you can do other stuff, and basically you can put in any you can put in any C++ Objective-C code, and it'll interpret it, or JIT compile. And whatever is the last statement of your expression will be the return value into Lldb of the expression. In Safari here, now, in the address space of Safari, now I love you rather, in Safari's address space, and now you can also besides these trivial statements that actually do not help you to debug at all, and you can type in, you can, right, you can type in any C, C++, Objective-C program and have it run inside the process. So the problem that I had basically was I wanted to see the regions, the permissions and so on for the memory regions. And one way to do it on the Mac then is to um, sorry. So you can run VM. Can you still hear me? I turned the volume down. Can you hear me? Can you hear me now? I'll just grab it in my hand. All right. So what you can do is you can run vmmap on the command line and then just look at the results and be like, oh, so if I have here my register RBP is this, I can just Alright, so I can just locate it here. And then I did the next obvious step, which is from Python, launch on the command line vmmap, and then parse it with regexes. And that was wonderful, but then on iOS, obviously you can't run stuff from the host on the command line in iOS because there's not even vmmap, so I had to find another way. And then, so these expressions then can be arbitrarily complicated, and then it's good to do it in Python rather than on the command line. And then, so this guy who wrote a book about OS X, iOS, whatever, and he published this command line standalone vmmap.c, which basically re-implements vmmap, but it's open source. So and then you need to do a lot of code signing and things where you have the plist XML with stuff in it, and then it's hard. But then because Lldb already has the get task prepared and everything, and it's already debugging the process, then this code will actually, because it'll be run in the target process, then you don't need to care about any permissions or whatever. So then you put in huge chunks of C code into Python, into string, and then you hope it compiles. And then because so basically because you'd include a bunch of headers where you'd have all these because you're calling some API which I think is Mac VM region here. So you're calling that API, and you have these structs that define the arguments and blah blah blah. So then you can't include any headers because you're actually in Lldb and not doing a standalone program. So you go into your Xcode and sorry, you find the headers there and well, that's good. And then you copy all these structs into your Python, and then because then the code was actually using something called vmaddress-t, which is in fact an int, then you have all these type defs that actually just define an int for the one thing that you're doing. And here's a %s, and then I combine for. So for iOS, this is the VM region extended info, blah, blah, blah. And this is the one for OS X. And then you string substitute them into this monster thing. And then you run the thing. But so the only place that actually has these Lldb things in existence is so when you get Lldb, it has this directory called examples, and basically here is what the Lldb people did on their own. Oops. And here's where I found how to do the type defs and monster string replacements. Copied from here, and then adjust them to actually do this VM map thing. So now, since this is like a cooking show, we started with I love snare, and now here's the completed thing. And since you probably want the, say you want it for R12, then you just get the results for this is what you wanted, and this is okay. Never mind that. So this is what I was aiming for, and I know this demo is on OS X, but this works equally on iOS as well. And because now, so while I do this, every time that C code is interpreted or JITted by to your target process every time you call this. So if you call it 10,000 times, then you get 10,000 of these mappings, which in turn makes listing the mappings harder. And then so there's this guy snare. I don't know if he exists, but you have this front end for Lldb or GDB as well, and I was using it, but it didn't have the features that I wanted. So here's normal disassembly for Lldb, and I'm on the top. So then I started drawing arrows into red arrow because I'm here to start the jumps. Now I can see where I am. But the feature that I really wanted was I wanted to, so here's R15. Now I want to see where R15 comes from and where it goes. So I want to highlight it when I mouse over it. So then I, inspired by snare, I did this wonderful graphical front end for Lldb, which draws the arrows for me. And now when I go on R13, it highlights that, ooh, here's R13. And here on the bottom, then I have the registers, and basically then I get the mappings and such for and the allocation size is for all registers. And does this presentation evoke any questions from you?
Yes, would you flatten over the black? Move it to the other side.
This? Alright, I don't know what happened. Good job. Thanks for waiting until the very end. Here's HTML. I also have CDT in Singapore. So for charity, it turns out that if you have a function, you bind it, and then you do instance off on it, then something, and then yes. Thank you, sir. So then here you do the C instance of C, which is supposed to be false, but instead you get the HTML element for 2BC. And that's all I have here. Hello? Thank you.
I don't support, why? You see the mic works very well with me.
Scottish.
It's the Scottish accent. I don't suppose you have any question, do you? Seriously, no question? You do? Are you kidding me? You actually understood what he said?
Can you get iOS binaries, or do you have to compile it yourself?
Let's compile it yourself.
So you're running Lldb on the host, right? And then you have the debug server that ships with Xcode that runs on iOS. And then depends on then what you're debugging, what the target is, if it's like something Apple wants you to debug or not, depending on that. But yeah, so you just it's not here. So basically, you just connect to the remote debug server, and so on iOS as well. Then previously, so you ran GDB locally on the phone, but now so you have debug server, and you connect to that from Lldb, and actually you don't have symbols on the phone either anymore, like you did with GDB. But then in these directories on like /application /xcode blah 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 platforms iOS whatever, then you have the symbols there. So then on the host you can fork out to ATOS and so on, and run ATOS, and then actually get the symbols for whatever you're debugging, if it's like a system library.
And where'd you get the debug server binary?
It ships with Xcode.
The iOS binary.
Yeah.
Can I stop me?
Like if you have the Xcode, the iOS SDK, then it ships. And then when you start, like from Xcode, you start debugging your own app, then it copies the binary over into like /developer something.
Can you attach to any binary, like just a random app store app?
I don't know. But yeah, so if you have your own app, at least you can do it. I don't know with other apps.